Hello, I'm Kim Sauer at Electronica 2016. I'm joined by Michael Ford from Mentor Graphics. Now, Michael, it's great to see you here, and there's a lot to talk about when we walk around these shows, but what I particularly want to pick your brains on is some of the requirements in terms of traceability and particular industries that applies to. So there's been some development towards more and more traceability. Would you agree that industries like automotive, medical, Milero are the key ones where it's very necessary, but it's getting even stronger in those industries?
Yeah, I think traditionally there's been a requirement for these industries to record information. However, we are now seeing the next generation of requirements, so it's not like an incremental increase. Actually, now people are being faced with the reality of having counterfeit material. And so, certainly in a medical device, something perhaps that would be implanted, would you really want to take the risk of having an issue with that? Traceability needs to be there not only to show that everything is done correctly and you can report that, but also to make people accountable. For example, if the material is found to be suspect, then you've got a range of accountability to go back to the source of where that product or the problem actually happened.
Very much in line with Industry 4.0, communication between machines, and that's becoming more and more sophisticated. And the other interesting point I hear out of that is traceability actually goes right back to the very start of the supply chain as well, right through to the end of it. How are the solutions and the equipment that's needed to be able to provide this level of accountability and traceability? Where are the developments there, and where is it going?
There are two key developments I see going on right now. The first is in the communication, as you said, from the machine. So open manufacturing language is out there, and it's not just a simple thing to gather information from machines. It also has to gather information from manual processes and also transactional things. For example, material verification, we need to know that that's done. And then it goes back to the point, well, where does traceability start? Because you're kind of logging boards through machines and they're using materials, but where did that material come from? How do I know that that's legitimate? And even the fabrication of the PCB itself. We've heard of problems with laminates being used which are not the correct ones. How do you know that known good starting point for where traceability should start? And that's the key thing that we need to gather, is the data from all of those kind of aspects.
So how do you approach that then? So where do you start?
Actually, a good starting point now is with the IPC. Because IPC 1782 standard for traceability is the first standard for electronics. Hard to believe, really, we're considering how long we've been making electronics, but it is the first standard that really addresses traceability of assembly and going back to all of these different kind of sub-assemblies and materials that make part of it, including mechanical assemblies as well as the fabrication of the board. So this new standard published this month is a vital starting point. From there you can understand then what data you're going to collect, and then you understand how you're going to collect it.
Okay, so standards are obviously very important, and there are constant discussions going on in that arena that will help progress in that. But is there also, because we're looking at a traceability across the supply chain, is the way companies have to interact to be able to communicate and provide that seamless communication, is that changing, and how do the companies within that environment have to adapt maybe their processes and their contacts to be able to cope with that sort of demand from their ultimate customers?
Right. Yeah, it's been a big source of issue for traceability in general, because it's the cost of the collection of the data and then having it in different formats from different companies and different suppliers. How do I understand the traceability of this sub-assembly if it was made halfway across the world and they didn't collect the data as I wanted it? These are the kind of key issues we looked at with the IPC standard, so that people can start to talk a common language. I want a certain level of traceability and I understand exactly what that means. So that when I get that information, then I know exactly what it's going to contain. It all fits into a hierarchical tree, so that you could read a serial number like of a cell phone, and you can go back down and see all of the circuit board components, the battery, the screen, and all of these other things very precisely, if you want to. So that highest level of traceability allows you to go all the way back to the original component compounds that the materials were made from.
And that's a point going back to the medical industry and the requirements there. Now, like you said at the beginning, you don't want a pacemaker that has some counterfeit or faulty components within that. Does that mean that industries like medical will require, well, additional levels of accountability that will require maybe possibly more investment or different type of equipment to be able to provide that level?
Potentially. We came up with 4 levels for materials and process. So level 1 is what people should be doing right now anyway, all the way up to level 4, which is the kind of extreme. Here's where you're collecting data from machines and putting everything together that you possibly can. The key point of that, though, is that traceability is always perceived as being a burden. You know, you're having to get machines that give you that precise information. You've got to try to get an automated feed of information from those machines. The open manufacturing language, OML, I mean, it helps to solve that problem. But, you know, information still needs to be gathered and put together in a way that it can be used very effectively for traceability. And I think by having the standards, it really allows people to talk the same language, to be able to put things together. And we're seeing that traceability becomes a net benefit for the operation. And just let me explain how that is, because people will see a cost of taking information. But that information can also be used for quality purposes. For example, maybe I make 1,000 products, and one of those is faulty. Okay, so you made all of the 1,000 on the same line of machines at the same time with the same materials in the same environment. How come one of them was faulty? These are the kind of one-offs that people have real difficulty to explain. Once you've got the traceability data, you can start to use your big data analytics and start to put together all of the different attributes of what happened, and you come up with a unique combination of factors that then caused that defect. So now instead of saying, okay, take that unit away for testing for 7 days because I want to be sure that my other 999 can be shipped, now you can look through your big data and say, right, okay, I understand we had this condition, that condition, and the other condition. This was unique. It affected only this product. It's completely consistent with the fault I found. Ship the other 999. It's safe to repair this one, and off we go.
And is that then also at the next stage predictive so that you can avoid?
Oh yeah,
those
absolutely,
type of
absolutely.
faults?
Because once you understand that combination, then you can say, right, even though all of these 3 processes were within tolerance, the combination was no good. So now with my live Industry 4.0 system, I can now be smart and look for that combination again and say, hang on, the oven is slightly higher than it should be. We know that this particular combination, I'm going to make this board wait for 30 seconds for it to get up to proper temperature. Things like that can be done.
So it's the reality of the smart factory, ultimately.
Indeed, all of these things kind of interact. Once you start to gather the data from the machines, you've got better control systems, you've got better conformance and compliance from a management perspective. Traceability is actually for free because you've got all of the information now. You've got a good active control against counterfeit. And so, the whole thing is part and parcel of this same thing.
Excellent. Well, thank you very much for your time today. Great talking to you.
Yeah, thanks very much.
Thank you.